Okay. So in section 8.5, we'll be looking at angle of elevation and angle of depression problems. And that will help us to set up a picture and put the angle in the appropriate location. So if you look at the picture before I reveal what the definitions are, the angle of elevation is from a line of sight up. That's why it's called elevation. You're looking and you tilt and look up at a certain angle. So that's why it's angle of elevation. So it goes from a horizontal line up to your line of sight. The angle of depression, again, has to be from a horizontal line. So up here, if someone were in this hot air balloon, they would be starting out looking straight. They might see something below them, so they tilt and look down. The angle of depression will go from a horizontal line down to the line of sight. Okay, now usually the triangle would be this one. So what do we notice about the angle of depression? What do we notice about it in regards to the triangle? Luke?
It's outside.
It's outside the triangle. So the angle of depression will be typically outside of the triangle. A lot of students, the biggest mistake is that if I tell you an angle of depression, they'll put it inside the triangle of the top part. The angle of depression will 99% of the time be outside of the triangle. Now, what do you notice about the angle of elevation and depression? They're the same number, right? Which would mean they're congruent. What type of angles would those be? Way back from chapter 3. Jeremiah? Yes, these would be alternate interior angles. Okay? And they are congruent because horizontal lines will always be parallel. So if you know the angle of depression, you can copy it down into the angle of elevation if it helps you, because then it's inside the triangle. Or if you knew this angle, you can also copy it up there. So formal definition, we have angle of elevation is the angle formed by the horizontal line and the line of sight to an object above. The angle formed by the horizontal line and the line of sight to an object above. Usually inside the triangle. The angle of depression is the angle formed by a horizontal line and the line of sight to an object below. You might want to jot down that this one is usually outside. And the reason I say usually is that typically the triangle you'll draw will have usually they give you like the altitude or the height of the hot air balloon or whatever. So you'll have a number here, which is why this will typically be your triangle. But does everyone notice that you can construct another altitude and you could create another right triangle? So technically this would be inside of this triangle. This angle would be inside of this triangle. So if you wanted to, you could draw another horizontal line in and create a different triangle if you prefer. But most students don't want to get overwhelmed and have two triangles. They like to just have one and then copy that angle down if you need to. So our first few questions just ask us, is it an angle of elevation or is it an angle of depression? So looking at angle 1, do we think it's an angle of elevation or depression? Is it from a horizontal line down to a line of sight, or is it a horizontal line up to a line of sight? Okay. Elevation or depression? Right? Depression goes from a horizontal down to a line of sight. Now it also asks us to describe the angle, so this would be from the mountain down to the hiker. Or to the person, whatever you want to say. Goes from the top of the mountain down to the hiker. That's what we're looking at. Angle 2. Do we think that's an angle of depression or an angle of elevation? What do you think? Joseph, what do you think? Angle 2.
Elevation.
Elevation. This one goes from a horizontal line of sight up to the peak of the mountain. So this would be elevation. And this would be from the hiker up to the mountain. I'll just abbreviate mountain with MT. Angle 3, elevation or depression. Brett?
Which one is number 3?
This one.
So it would be depression.
Sorry, I thought I heard you say it. That's why I called it you. I heard you like saying it. So be depression. And this is going to be from the hiker down to, I don't know, the house, the cottage, the cabin, something like that. Or you could say down to the stream, something down at the bottom. And then our last one would be, Chet, what do you think for 4?
Elevation.
Elevation. Good. Going from the cabin up to the hiker. And that's if the cabin could actually see people it would be looking at. But we're just kind of connecting this. So the rest of the problems, you will notice there are no pictures. You are going to have to draw one. And you're going to have to label appropriately the sides or angles that are given to us. And then we'll use SOHCAHTOA to find out what the missing measurement is. So we'll start out nice and easy. Tree and a shadow problem. Remember we used to have the similarity, like person in its shadow, building in a shadow. We'd have 2 triangle pictures. This one's only going to have 1. So you'll see on my slides that I have clip art put in because my drawing is just god-awful. I mean, it's just really, really, really bad. And you'll see that with my tree, because that's the only thing I'm going to draw on here. For those of you that are good drawers, feel free to draw it beautiful. For those of you that are bad drawers, you can just put a circle or a dot or an X or write the word boat. Like, you don't have to make it a pretty in terms of the picture part, but the triangle is important, so you do have to sketch a picture in regards to that. So we have our tree. Should have chosen green. Actually, this isn't turning out so bad. It's like the Berenstain Bears. Okay. A tree is 10 meters tall. So the height of the tree is 10 meters. The tree casts a 17.4 meter shadow. Remember, a shadow goes on the ground. Does not go through the middle of the air. This would be 17.4 meters. Find the angle of elevation to the sun. Now we're assuming that the sun is somewhere over here because in order for the shadow to fall on this side, the sun has to be on the opposite side. Therefore, the tree is blocking some sunlight, creating a shadow. Okay, so you have the sun kind of like coming down over, creating a, surprise, surprise, right triangle. And we're shocked. So they want us to find out the angle of elevation to the sun. So remember, angle of elevation is going up from a horizontal. So we're going to go from the horizontal up to the line of sight, which would be the sunlight line. And we'll put a variable there, x degrees. Now we just go back to what we learned last week, which is SOHCAHTOA. Which trig function am I using? Sine, cosine, or tangent? Maddie? Tangent. Based on this being my angle, this is my opposite side, and this would be my adjacent side. O and A, tangent. Okay? So we'd have tangent of x equals 10 divided by 17.4. How do I solve for x? Switch them around, right? When I switch them around, I'm taking the inverse tangent. And that goes right in our calculator. Again, make sure we're in degree mode in case anyone switched calculators or is borrowing one of mine. Make sure it's in degree mode. And we will round to the nearest degree. So what would this be rounded to the nearest degree? 30. Joseph. No. Only if you're doing anything with trig. It won't affect your graph or anything. Alright, now they get a little bit harder. A great white shark swims 22 feet below sea level. If the shark is 67.6 feet from the sailboat, what is the angle of depression of the boat to the shark? So first of all, you have your boat. If I were drawing a boat, it would look like that. Okay, just so everyone knows. It does not need to be a fancy drawing. You can even just put a circle or a dot and say boat. But the more realistic you make the picture, the easier it will be for you to interpret what's going on. Now the shark is somewhere swimming below the boat. Now it's not directly underneath the boat. Okay, we want to realize that it's off to the side somewhere. But they do tell us that it's swimming 22 feet below sea level. And it is 67.6 feet from the sailboat. So if you were to connect the sailboat to the shark, this is 67.6. Now remember, elevation and depression all stem off of a horizontal line. So you would want to take and sketch in a horizontal line from the boat and even possibly from the shark. Because elevation and depression all stem off of horizontal lines. So you have to have horizontal lines. Now it's up to you, 22 feet below sea level, the shark. You can either put that here to here and call it 22, or you could put it here to here and call it 22. It does not matter which one you put. Most students will put it here because it says from sea level, but again, you can put it here or here, it doesn't matter. And this would be 22 feet. What is the angle of depression of the boat to the shark? So depression goes from a horizontal line down to a line of sight. So it would go from here down. Now, this depression actually falls inside my triangle the way I drew it. That's why I said it usually falls outside. It would fall outside had I have drawn the 22 here, right? That angle would be outside of the shape. But this time we decided to draw it that way. So we'll put an X there. What trig function should we be using this time? Put it on a right angle. What do we think? Sine, cosine, or tangent? Mira? Sine. So we have our opposite, and we have our hypotenuse. So that would be our katoa. So this would be sine of x equals 22 over 67.6. Again, to find an angle, we have to use the inverse. Hi. Oh, okay. Oops, almost forgot my inverse there. And then we should just punch that into our calculator. Round to the nearest degree. So once you have the picture, it's a problem from a worksheet. That's not the hard part. The hard part is constructing the picture, because if the picture's wrong, then you're going to choose the wrong trig function, and then you're going to get the wrong answer. Okay. So I will model as many as you want, but really the best way for you to practice these is practice drawing them on your own, and then we can kind of go over it. Why don't you guys try setting up the next one, and then here you are. That's right. I know. You cite a rock climber who's on the cliff. At an angle of elevation of 32 degrees. So again, if you have an angle of elevation or an angle of depression, you have to have a horizontal line. If you want, you can draw the other one. Some students just always like to draw both of them, and it makes the problem easier to them, if you'd like. You don't have to, though, because the only time you're going to need the top one is if it's an angle of depression, because you'd be going down. But we're going to use the angle of elevation, which is from you to the person. Now, they don't tell you how tall you are. Sometimes they will, and then you'll have to factor that into the problem. Since they didn't tell us how tall we are, we're just assuming that, like, basically we're going to form this angle with the ground instead of from our eyes, and have that difference in height. 32, angle of elevation. Elevation, again, goes up from a horizontal. So that's our horizontal. Up is 32. The horizontal ground distance to the cliff is 1,000. So the horizontal distance to the cliff, 1,000 feet. Find the line of sight distance to the rock climber. Sometimes it will just say find the distance to the rock climber. If it says distance, a distance from point A to point B is the shortest distance that connects the two. So that would be our hypotenuse, x. You might want to just go ahead and make a, and I'm assuming this cliff is really 1,000 feet to here, I guess. My picture kind of draws it going in, but. What trig function will I choose? Sine, cosine, or tangent? Cosine, very good. We have our adjacent side, and we have our hypotenuse. Now this time I'm going to use regular cosine, not inverse, because I actually know the angle. Cosine of 32 equals 1,000 over x. Remember, this is the one that takes 2 steps to solve. You have to undo division with multiplication, just like we did in the bell ringer. Then you have to undo multiplication, again with division. This time dividing by cosine 32. And it doesn't tell us what to round to, so let's just do the nearest foot. What do we get? Joseph? Good. 1,179 feet. Okay. Next one, we got a plane. An airline pilot sights a life raft at a 26-degree angle of depression. And yours looks like a 0. It should be a degree symbol on your note sheet. I think it turned out like below the, somehow that got switched. The plane's altitude is 3 kilometers. What is the plane's surface distance from the raft? So we have our plane, we have our life raft. Make sure you don't draw the life raft as being directly below. He is not looking below his plane. He's looking out in front of him and looking down in front of him. You could have it going the other direction. It doesn't really matter. So in this problem, we definitely want to have 2 horizontal lines. We want to have the plane and we want to have the water, if you want to make this like lifelike. But we are going to assume that it is horizontal, even though waves would have some sort of curve to them. All right, altitude. What does altitude mean? The airplane's altitude. No? How high up it is. Think if you're in a plane, they're like, oh, we've reached a cruising altitude today of however many miles. So that's going to be the perpendicular distance down to, just like in a triangle, we have the altitude is perpendicular. And this will be 3 kilometers. And this is a line of sight to the raft. Now, the 26 degrees, this is the big problem. Where do I put it? Do I put it here? Do I put it here? Do I put it there? So this is 1, 2, and 3. Which one do I pick? 1, 2, or 3? Hold up your fingers. I'll say it again. This is 1, this is 2, this is 3. Raise up your fingers, 1, 2, or 3. So I can see what you think. Okay, I'm seeing about 50-50 between 2 and 3. Should be 2. Remember, the angle of depression goes from a horizontal down to the line of sight. So the depression has to go from the horizontal down to the line of sight. So 26 should go right here. Now, this is now outside of the triangle. Like I said, most of the time it will be. So you have two options. You can either take the 3 kilometers and create another segment over here, 3 kilometers, or what I prefer to do is just copy and paste that down here because the angle of depression will have to be the same as the angle of elevation. And that's because that those are alternate interior angles which will be congruent. So if this is 26, this is also 26. And then we need to put, they give us a d variable instead of an x. They want this plane's surface distance. So the surface would be the water surface or the ground surface. So we would put a d or an x there. Now another option you do have is you should know that both of these angles at the top do make a 90-degree angle. So if you prefer, you could calculate what this angle is by doing 90 minus 26. That's up to you, but most of you will prefer to use your alternate interiors because then you don't have to subtract. All right, now trig function, we have opposite and adjacent. So we should be choosing our tangent, our TOA. So tangent of 26 equals 3 over d. And multiply by d on both sides. Divide by tan, 26. And let's ahead. Oh, actually this one I think I rounded to something different. But we could do nearest kilometer since we don't have a direction. 6. Alright, see if you guys can try the 2 closures, sketching your picture and solving out for your missing. We're going to get 2 of you to the board to draw your pictures. My planes are terrible hand drawn. They look like blimps. Oh, there is a typo in example A. It should say how many feet instead of how many miles. I'm not going to make you convert miles and feet. So go ahead and switch that. How many feet from the airport? So for this one, we should have put our x along the hypotenuse because it says the distance from the plane to the airport. So in this case, we should be using opposite and hypotenuse, our sine function. And then we would solve, multiplying by x. And then dividing by sine of 3. The last one says we have a kite. The string is 150 feet long and it makes an angle of 45 degrees with the ground. Assuming the string is straight, how high is the kite? Now remember, if you're flying a kite, your kite is not going to be directly above you. it's going to be in the wind out somewhere over here. Okay. So the string, this is the string of the kite, that's 150 feet long. It makes an angle of 45 degrees with the ground. How high is the kite? This would be our x. This is the height of the kite. And so for this one, we would then choose our sine function again, because this is our opposite and our hypotenuse. So sine 45 equals x over 150. And this one is the shorter solving. We have x divided by 150. The inverse of dividing is to multiply. And then this goes into our calculator. And I should get 106 feet. Doesn't tell me what to round, so I'll just do a whole number. Okay, on the homework you have some word problems. You will see some that maybe require you to actually know how tall the person is. In the event that that happens, you'll just have to notice, like if this person is 5 foot tall, that this would also be 5 feet. So once you find the value of x, you just have to add 5 to it at the end of the problem.